Hello everyone, my name is Mirko Sinico and I'm ESR 3 in the PAM² project, performing my research at KU Leuven in Belgium. And today, during this final project meeting, I will present a brief recap of my studies. This presentation is subdivided in four main chunks, which reflects the four tracks of my PhD. Track 1, at the beginning of my PhD, was the development of an industrial case study, which was provided by the PAM² project and consisted in an injection molding insert for the production of ABS parts. On this mold insert, together with ESR1, we applied different topology optimization algorithms, taking care of different additive manufacturing constraints and using both commercial and in-house software. Out of the analysis, we selected one promising design, which had in total a volume of 50% compared to the original part, and also most interesting, the processing time by laser powder diffusion was reduced by 43%. Now, some features in this mold insert are more critical than others. For example, the top surface and the surface inside the cavities of the mold, they need to comply to very strict requirements in regard to their surface finish. For this reason, we try to study how to improve the up-facing surface quality of the LPBF parts, trying to connect the powder properties to the final part properties. To do that, we acquired three different batches of maraging steel 300 material. Track 2, therefore, starts with an in-depth characterization of the powder using different equipments, but I want to focus your attention on the microcity analysis. The microcity analysis was specifically devised to enhance our comprehension of the initial powder properties. A new characterization workflow was developed, starting from the definition how to prepare the specimen with the powder, to the microcity scans, the surface determination done initially on commercial software, but afterwards also through a MATLAB in-house developed software. To compensate for some of the inaccuracy of the microcity, some correction factors were investigated, like the use of a calibrated artifact to consider the voxel rescaling factor, and the use of different surface determinations depending on the density of the metal being analyzed. Combining all of these studies, it was at the end possible to derive with one CT scan all the information like powder distribution, powder shape, powder porosity, and also eventually powder contamination. At the end, out of the LPBF parameters optimization and powders investigation, we were able to derive optimum processing condition where using a selected distribution of powder, not only we decreased the surface roughness by more than half compared to the industrial batch standardly used in industry, but also we derived novel remelting strategies specifically for finer powder distribution to further increase the surface finish. This holds true not only for 0 degrees up-facing surfaces, but also for inclined up-facing surfaces, of course with different degrees of improvement. Thanks to these achievements, it might be possible to skip some of the post-processing steps necessary for our mold inserts to reach a polishing state of the top surfaces. Finally, other critical features for inserts are holes and bores, not only for channel purposes like conformal cooling channels, but also for features like mounting holes, the centering holes, and finally the ejector pins. For this reason, together with ESR 6 and 13, we derived LPBF benchmarks specifically for the investigation of channels in the range of 0.2 to 16 millimeters, produced in margin 300 but also in Ti64 and aluminum alloy, and optimized for batch micro-CT investigation. While we collaborated for the definition of the benchmarks and the analysis approach, specific goals for this last year of my PhD will be the investigation of the influence of the powder again, but in this case in regards of the developments of defects like sag and rust formation in the upper wall of the horizontal or inclined channels, and as well the influence on the powder for the amount of bowling and the sintered powders inside channels, which can be important for fluid flow and the application in the mold. A last line of study will be comparing a contour-no contour approach during the slicing and etching of the layers in LPBF to connect this parameter to the final surface finish inside the channels. This last slide acts as a recap of the journey of my PhD. I want to thank you for your attention and please contact me if you have any question. Finally, a heartfelt thanks to all the ESR and supervisors of PAM². It was an amazing experience. Thank you.